The John Burton building is situated at the rear of the Lincoln University campus near the NRE building. The building was originally constructed as 3 separate buildings as joined at a later date. As you can see in the aerial view, the building seems to be built prior to the completion of the George Forbes Library between the 1930s and 1960s. The materials and designs are consistent with building types of that age. The building was probably designed by the Ministry of Works. Like many additions to the campus during that period, we were unable to identify the designer or the engineer. We have provided a picture of the floor plan, but due to the interconnected nature of the building, they are difficult to measure and the provided floor plan is not drawn accurately to scale. Although the approximate floor area is about 425 metres squared, the building is currently being used as offices for staff and postgraduate students of the Department of Agricultural Science. It houses a common room, kitchen, toilet facilities in the central block. The building comprises a light timber frame clad in weatherboard with a corrugated iron roof. The interior linings vary and are a mixture of vertical TNG, plasterboard and tempered hardboard. Originally fitted with timber joinery, an aluminium sliding door has been installed in the common room. The John Hayward Room and West Building retain a suspended timber floor, but the floor in the central building has been replaced by concrete. The building has a light timber frame structure with an unusually low perimeter wall foundation and likely rests on concrete or wooden piles. It is difficult to distinguish the type of foundation used due to the extremely low floor height. The building systems are dated but in a serviceable condition. The current layout and fittings seem to be adequate for the current use of the building. These fittings and fixtures, however, could be modernised. There is some earthquake damage that resulted in the top of the chimney being removed. The base, however, remains and has been closed off. Due to the building's age and construction technologies, this building is not energy efficient. It is unlikely to be insulated and the majority of the windows are only single glazed. This issue is not easily addressed. As you can see, the building warrant of fitness has not been updated this year. It shares the same warrant of fitness and compliance schedule as the rest of the campus and has no information specific to the John Burton building. The building is generally in need of updating and modernising. The internal ceilings and wall lining in the common room are in need of repair with what appears to be water damage to a small portion of the ceiling. This looks like it may have been there for some time, which demonstrates that there may not be effective maintenance programs in place. The only recent structural upgrade that has been done to this building include an aluminium sliding door which was installed in the common area, and also midway through last year in the John Hayward room a partition wall was constructed to provide a meeting space. The internal floor covering appears to be dated but not heavily worn, which suggests recent replacement. The interior walls have been repainted in some areas such as the timber panelling and the entranceways, but other than that the paintwork is generally tired and needs updating. The interior ceiling is slowly deteriorating with evidence of water damage which is pulling away the ceiling lining from the internal framing. The interior fittings, such as the kitchen facilities, are basic but seem to be in a reasonable condition for its age. It could be upgraded, but it is not obsolete. The toilet facilities are also functional but dated, with galvanized steel piping. Due to its age, the galvanization may be wearing, causing the pipes to rust from the inside out. We were unable to see signs of the rust, and water pressure is also good. To increase the functionality and safety, the building has been retrofitted with modern structured cabling and fire detection systems. The fire protection systems uses what looks like heat detectors, but it lacks a manual call point and doesn't appear to be connected to the fire brigade. The alarm panel is also not easily accessible from the outside. Each building has its own power distribution system, which may complicate maintenance, but it also allows for sufficient capacity as a whole. The heating system is a mixture of electronic and central heaters powered by the campus boiler. There is at least one heater in every room, sometimes more, which goes to highlight the poor thermal efficiency of the building. The roof cladding has deteriorated and needs repairing. Some parts of the gutter need repairs, but other parts are in a reasonable condition. Some of the downpipes are newer than the guttering, which may suggest that they have been replaced. The exterior wall cladding appears to be in a relatively good condition, but in need of repainting. The window frames have deteriorated, which appears to be due to moisture. Several windows have been taped along the opening, which is an attempt to prevent any draft. The foundation parameters wall is in good condition with no spalling. We couldn't examine the subfloors but assume it is resting on piles. The building also has a low floor height, possibly due to the ground being built up around it as the area was developed. The inspection of the building was undertaken on a warm day, so there was no evidence of mildew or condensation. However, the windows are single glazed, and without seals, this could promote mildew growth. Due to the condition of the building and that it is nearly at the end of its useful life, it would be financially infeasible to remedy the usability defects, such as upgrading the kitchen and toilet facilities. There is work that should be done to continue the occupation of the building. This includes cosmetic, like repainting the interior doors. The potential water damage in the common room may need to be repaired to prevent further damage. Some attention is also needed on the exterior of the building. The cladding and the timber window frames will require repainting to prevent water damage in the near future. There is a high number of heaters. The poor thermal performance of the building cannot be easily fixed. This will have a significant effect on the operating expenses of the building. After inspecting the building, we have assessed that because the building was built prior to the 1960s and is already over 50 years old, it is nearing the end of its useful economic life. The building can retain its current function with some maintenance, but going forward, the maintenance costs will increase. As it is located on a university campus, there are limited uses for the building other than office space. The size and layout of the building limits it as a lecture theatre, but it could be used for equipment storage. The building doesn't show any structural defects, but the water damage could reveal more serious problems. It may be a result of poor workmanship during construction or be due to leaks in the original piping that is wearing out. It may also indicate a lack of adequate maintenance. The building is a single story with light timber frames. It likely complies with current earthquake regulations. Because it was built before the 1970s, further inspections with an IEP would be required to determine its seismic strength. The low floor height and piecemeal construction may cause issues. An assessment by a building inspector or engineer is recommended to get a more accurate understanding of the building's condition. Advice from a structural engineer or building inspector on the foundations and connections between the building elements would improve this report, as we could not determine this from our inspection.